If you do microsoldering, you know this exact headache. Solder balls fusing together, paste spilling over the pads, and a completely ruined grid. Today, we are going to eliminate that guesswork. We will walk through a repeatable method to get perfect alignment and uniform solder spheres on your first try, even when using a universal stencil. First, you need the right setup. The integrated circuit, or IC, must be completely stripped of old flux. If there is even a trace of residue left on the chip, the process will fail before it starts. Nailing this clean baseline is what separates a frustrating gamble from a guaranteed short-circuit-free motherboard repair. Step 1. Prepare your surface. It needs to be completely flat. Place a half-folded piece of tissue paper down, set your thoroughly cleaned IC on top, and position your universal stencil directly over the chip. A major point of failure at this stage is the stencil shifting while you work. To lock it in place, apply a quick, light burst of heat to the stencil. This settles the metals securely against the IC. Next, we prepare the solder paste, or PPD. This is a crucial variable that many technicians skip entirely. Take your paste and squeeze it tightly inside a completely dry piece of cloth. You are physically wringing out the excess moisture from the compound. This cross-section diagram shows why drying the paste matters. When you apply heat, any trapped pockets of water will quickly boil and expand. That rapid expansion violently ejects the solder paste right out of the stencil cavity. By securing the stencil and drying the paste, you eliminate these invisible blowouts before you ever pick up the heat gun. Now gently fill the stencil. Use a light hand and apply the dried paste in a single unidirectional swipe, moving evenly from one side to the other. Do not go backward. Wiping a second time over areas that are already filled will pack too much material into the holes and ruin the sizing. Once filled, gently wipe the top of the stencil with a dry cloth. Pay close attention to the corners. Cleaning the excess here prevents the corner solder balls from swelling larger than the rest. Anchor the stencil firmly in place using a pair of bent tweezers, and grab your SMD hot air gun. This vector diagram illustrates exactly how we apply the heat. Pointing the nozzle straight down creates high turbulence that blasts the paste out of place. Instead, we use an angled airflow to smoothly transfer heat across the surface without disrupting the microsolder. Move your angled heat slowly and steadily across the grid. You will see the matte gray paste rapidly coalescing into perfectly smooth liquid metallic spheres. Pushing the thermal energy laterally across the metal is exactly how you keep the solder constrained to its designated pool. Immediately inspect the freshly melted grid. Scan for any dull spheres or balls that failed to bond with the contact pad underneath. To correct a loose sphere, apply a microscopic dab of flux strictly to the stubborn ball, then follow up with a brief, targeted pass of heat to force the bond. You now have a strict 10-second window. While the IC is still warm, use gentle tweezer pressure to safely separate and remove the stencil. Because we used a universal stencil, there is a specific byproduct: isolated stray solder balls resting directly on the chip's surface, outside the active pads. Take your tweezers and manually flick every stray ball away. If a single stray sphere is left behind, it will short-circuit and kill the motherboard the second you mount the chip. Microsoldering relies entirely on this final cleanup. One microscopic piece of leftover metal turns an otherwise perfect procedure into a fatal hardware error. To verify the chip is ready for installation, start with a side profile inspection. Every single solder ball must sit at the exact same uniform height. Finally, perform the diagonal verification test. Rotate the IC and sight straight down the rows from corner to corner. You are looking for mathematically even lines, no bridges, no gaps, and absolutely zero misalignments across the entire grid. When your grid meets that strict geometric standard, the CPU is safe, fully functional, and ready to be remounted to the board. Try this method out and let us know your results in the comments below.